Today in this video, we are going to look at something in Python known as collections. And collections are different containers that we can use to store collections of data. The built-in collections that we're going to take a look at today are lists, tuples, sets, and dictionaries. And after watching this video, you should have a basic understanding of the differences between these different collections and be able to perform some basic operations on each type of collection, like inserting new elements into the collection, removing elements, etc., etc. So the four collections that we're going to talk about, lists, tuples, sets, dictionaries, we'll go through and talk about some of the unique characteristics of each and look at some examples of how to manipulate these collections and also kind of what is the closest thing to this collection in JavaScript, since a lot of people are coming from a portion of the curriculum where you have been working with a lot of JavaScript. And it's just nice to compare how you do the same thing in different languages. So let's get started with lists. So lists are very similar to JavaScript arrays in that we have a group of items. We can refer to those items, reference them by their index. The order of the items is not going to change unless we go in and change them. Lists are mutable and they allow duplicate items. We can have multiple of the same thing. And I just want to make sure we all know mutable versus immutable. You will hear these terms from time to time when you're talking about different data structures. And so basically all it means is, can we change the contents of this thing or can we not change it? So if we say something's mutable, we can change it. If something is immutable, once we create it, we cannot make any changes to it. But lists are mutable, so we can change them. So creating lists is actually very similar to creating arrays in JavaScript. So as we go through, the JavaScript examples will be on the left, the Python will be on the right in blue. So creating very similar, we use the square bracket notation that you should be familiar with. If we want to insert items into our list, we have a couple of different options. We can add items to the end of our list with the append function, or we can insert them at a specific index using the insert function, which will then shift everything else over to the right to make room for the value you are inserting. We have several options when it comes to taking something out of our list. We can either remove an item by its value, so that remove function in Python. So like in this example here where we are removing orange, this will remove the first instance of orange only. So if there are multiple instances and if you want to remove all instances, you would have to do a little bit of additional checking to make sure that happens. Other than remove, we also have pop, which will remove the last item in our list. Or we can use del, the del keyword, short for delete, to remove an item at a specified index. And traversing, so we can traverse lists just like we can traverse arrays. Really the only difference in the code you see for traversal. It's more to do with the fact that loops in Python look a little bit different from loops in JavaScript. But you can still traverse using indexes starting from the beginning and using the length to determine when you're at the end of your list. Right. A couple of other things we can do in Python with our lists that is pretty useful. So we can use slices in Python just like we can use slices in JavaScript. The notation is a little bit different. So in JavaScript, we had a slice function that we could call. However, in Python, so if you look at the example primary colors where we are taking a slice or a sublist from the original list, we're taking just a piece of that. We have two indexes that tell us where that slice, where that new piece should start and where it should stop. So the first index, the 0, refers to the first item in the original list that we want to keep. So by saying 0, we're saying, okay, start with the very first thing. In this example, that would be start with red. The second number, the second index, is referring to the first item that we do not want in our slice, in our new list that's being created. So in this example, orange will be the first thing that we do not want. So primary colors will contain red and yellow only. A couple of other things that we can do with our list slices. We actually we don't have to include either the start or end index. And what that will do, what that indicates if we omit this value, in the case that we omit the second value, that means we want to go all the way to the end of the original list. So that second example, that slice would contain the values yellow and orange. We're starting with yellow, going to the end. And if we don't include the first index, that means we're going to start at the beginning of the array. So we're going to, by not including 0 or 1 or anything before the colon, that means, okay, we're going to start with red, go to yellow, not include orange. So actually the first and third examples will return the same slice. And in Python, another thing you can do, if you don't include either value, if you omit both values, and just in your square brackets have a colon, that will actually create a copy of the original list. So if you need to create a copy, that's a nice, concise way to do so. And then the final thing I want to mention when it comes to lists are list comprehensions. And this is a way for us to create a new list from another list that meets some criteria that we have defined. So for example, the example that is here, so we're sticking with colors, but I've added a few additional colors to the original list to make things a little more interesting. What this new colors list comprehension will do. So a list comprehension, you can see it starts and ends with a pair of square brackets. It's going to return a new list. So that variable new colors will contain a new list. Okay, so let's break down how this list comprehension is working. So we see this here, which should look relatively familiar for C in my colors. All right, well, that sounds like a for loop that's going to iterate through all of the colors here in my colors, okay? But we're not necessarily going to include every single color from the original list because we have this condition here. If the length of that color is less than 5. So if I look at my original list of colors, there are only 2 colors whose length is less than 5, red and blue. And then the other part of this list comprehension we want to make sure that we take note of. So why do we have this C at the beginning? Well, that basically says add the color as it appeared in the original list. So I could, for example, take that color and maybe slice it to only include the first 2 or 3 characters. I could call some different string functions on that to either force it to be uppercase or lowercase. So I could manipulate these values before putting them into my new list, but in this case, I'm not. So by saying C for C in my colors, I'm saying, okay, use the original color, the original value for every value in this original list where the length is less than 5. And we can do the same thing in JavaScript. You can see over to the left the loop and the if statement. That's going to do the same thing, but list comprehensions are a nice, concise way to kind of filter your lists in different situations, right? All right, so let's move on from lists to tuples. So tuples, again, they're another collection of items that we can reference by index. However, they are immutable. We cannot change the values in a tuple once it has been created. So let's take a look at what a tuple looks like in Python. So instead of using the square bracket notation, we are going to use parentheses when creating our tuple. But remember, they are immutable. So we cannot add values to our tuple. We cannot change the value at a particular index in our tuple, and we cannot remove values from the original tuple. All that we can do with this tuple is we can access the length, and we can traverse it, maybe print out the values, use them as part of some other function or operation. And there's not really a good equivalent to this in the built-in classes in JavaScript, right? We also have available to us in Python sets. So sets, they are mutable, right? So we can't necessarily change values in our sets. We can add values to our sets. But sets, unlike lists and tuples, do not contain duplicate elements. So let's say that we create a set of cities, and you'll notice here we're using curly brackets to create our set, right? So creating a set of cities, I can add new sets in add new cities to this set in a couple of different ways. So I can add single elements with the add function, or I can use update to add multiple elements at a time. I cannot change items at a particular index like we could with lists, because with sets, there's not really a set order to how the items are being stored. So we don't have the ability to reference items by an index. They're not assigned an index that will remain the same. We can remove items in a couple of different ways. We can remove by their value. We can pop to remove the last item that was added to the set. And like the other collections we've seen, we can access the length and we can traverse that set using a for loop, right? And then the very last collection I want to talk about are dictionaries. So dictionaries, they are mutable and allow duplicate items similar to lists, but unlike lists, we do not reference items in dictionaries by an index. We reference them through keys. So we have a group of values, and they're stored as key value pairs. And we will get into more detail later on in the curriculum about how dictionaries work. But for right now, I just want to make sure everyone is familiar with how you can use them in Python and just how the syntax works. So they look very, very similar to objects that you might have seen in Python. Objects that you would have seen in JavaScript. You will sometimes see people use JavaScript objects in a dictionary-like manner. So here on the right, we have a dictionary of grades where the key is the name of the class or the subject, and the value is the grade in that particular subject. We can access values using the get function and entering the key as a parameter. We can add values to our dictionary by simply using in square brackets a key that does not exist. If we use a key that does exist, for example, English, you can see it was in the original dictionary when we created it. So this will not add a new key value pair to the dictionary. It will update the existing value so that English grade that was a 91 will change to 93. And there's a couple ways we can remove. We can either remove a specific item by specifying the key, or we can pop to remove the last item, pop item. And like all the other collections we've seen, length is accessible to us and we can traverse with a for loop. So in summary, just want everyone to be aware that there are several different data structures that are built in and available to us in Python. They each have their own pros and cons, right? Some are they're going to have different operations available to us. Some are mutable, some are immutable, some allow duplicate items, some do not. So depending on what you're doing, you might want to use a different collection. But a lot of them, there's actually a lot of similarities to data structures that you've seen in other languages.